Okay, so now we're going to take a look at the reciprocal trig functions and what their graphs look like. Cosecant, secant, and cotangent. So let's start with cosecant. Remember, cosecant is the reciprocal of sine. So we're going to take and use that as our guide, sort of. So when we think about sine, remember sine is y, and at 0, it's 0, right? And if I take the reciprocal of 0, 0 over 1, flip that around, that's going to be undefined. So wherever I have 0, this will now be undefined, which means then I really have an asymptote line to represent an undefined spot. So really, wherever I have a 0 on sine, I'm going to end up with an asymptote. So that means here at pi, where it's 0, at 2 pi, where it's 0, okay, and then back the other way as well. Okay, so those are my asymptote lines. That actually makes it a little bit easier to graph. Okay, I should make my eraser a tad bigger, but okay. So I'm going to draw in my asymptote lines. There they are. Okay, now when I'm at 1 right here for sine, that would be the same for cosecant. The reciprocal of 1 is still 1. So if I do, right, pi over 2, reciprocal of 1, I still get 1. So I have a dot here, okay? If I go to pi, I end up with 0. For sine, reciprocal, I get undefined. But if I go to 3 pi over 2 down here, I'm at -1. And I would do the reciprocal, I get -1. Okay, what happens in between here? Well, at pi over 4, so let's say we're right here. At pi over 4, we would take the reciprocal of square root of 2 over 2. So that would be 2 over square root of 2. If you type that into your calculator, you get about 1.4. So, you know, it's something like right around here. All right, now if I do that at 3 pi over 4, I also have the same thing, so it's something like right here. Now, really, what you get is this kind of looks like sort of like a mini parabola. Draw this a little bit better. That gets really close to these asymptote lines, but remember, they can never touch. Now, this one here at, let's do 5 pi over 4, it's -1.4 if I flip that around. So it's going to be something like this, and then over here like this. So I get this shape. Now, if I continue, then I would have another one over here, and then it repeats. So really, I have 2 sections before it repeats. One with the parabola sort of, it's not a parabola, but sort of looks like a parabola facing up, and one facing down. So that's where it repeats. Now this cycle repeats, so my amplitude for cosecant is still 2 pi, okay? The period, I shouldn't say amplitude, I should say the period is still 2 pi. The amplitude is undefined because it keeps going all the way up or all the way down. My asymptotes, you can see they kind of lie at 0, pi, 2 pi, and then back the other way, -pi, right? And then just, so every multiple of pi. So I can continue this graph. It's going to look the same going the other way. And then one up here. And that's the cosecant graph. It's not too tough to graph these ones because the asymptote lines really help with this part. Okay, let's take a look at secant. So secant graph is the reciprocal of cosine theta. Now we know that cosine starts at 1, okay? So you can use your unit circle or you can just use this graph to kind of guide you. The graph might be a little bit easier for this, so maybe that makes more sense. So we know at 1 is at 0, 0 is at 1, so the reciprocal is still going to be 1. Now here at pi over 2 is 0. Now the reciprocal of 0 is undefined, so this is where I would have my asymptote line here. Okay, I would also have another one right here, and that's at 3 pi over 2. Okay, so really, then if I go back the other way, every 4 squares I'm going to have an asymptote line, so I could go back this way. Okay, and now all right, so there's my asymptotes. Now this one is going to look very similar, just it's a little bit differently placed. It's going to look very similar to my cosecant graph. So let's go back to my color here. At pi over 4, if let's do the reciprocal now of cosine, so that would be 2 over square root of 2, and it'd be 1.4 again. So I'm going to get that same kind of situation. If I go the other way, I'd get this. All right, now if I go to pi, I have -1, take the reciprocal, I get that. So now it's going to look like this. And then I can fill out the rest of this. Okay. Okay. Now amplitude, the amplitude of this, again, undefined because it keeps going all the way up or all the way down. The period is still 2 pi. This is 1 pi, here's another pi. Remember, it's got to do the up and the down before it repeats. So, and then the asymptotes on this one are at odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, etc., and negative pi over 2. Those will change, but for the original one, it might help to write that in there, so you've got it. Okay, now cotangent, what does it look like? Well, cotangent, reciprocal of tangent, we know that tangent is y over x, so cotangent be x over y, but again, it might be more helpful to look at this is the tangent graph, so this is tangent theta, and I think it's a little easier to look at this instead of the unit circle, but either way, same thing, right? Okay, so this is the tangent graph, and I notice right here, it's at 0, and at pi. So what happens here is then wherever it's at 0 for cotangent, I should have an asymptote line. So that means I'm going to have an asymptote line right here. And I'm also going to have an asymptote line right here. And then, you know, I would have another one right here. Okay, and back the other way. Okay. Now, where it's on our other graph here, where it's at an asymptote line that's undefined, where 0 is in the denominator, if you flip that around, you'd have 0 over 1, which is 0. So another way to look at that is if I could go to pi over 2, and I would say, normally it's y over x, it'd be x over y, 0 over 1. So that's going to be 0. So I can use there we go. At pi over 4, right? Pi over 4, I would have x over y. It would be square root of 2 over 2 divided by square root of 2 over 2. That would be 1. And then if I go over here to 3 pi over 4, it's going to be negative 1, because I would have negative square root of 2 over 2 divided by square root of 2 over 2. Okay, so one of these looks very similar to tangent. It's just flipped around. It kind of looks like this. Now this will repeat. That's one cycle. So you can see my period there is pi. The amplitude, once again, on all of these reciprocal graphs is undefined. Now my asymptotes lie at pi, 2 pi, etc., and at negative pi, negative 2 pi. Okay, so really, this makes this one a little bit, one of the easier graphs to modify, because the period is the same as where the asymptotes are, so that really helps make it a little bit easier to graph, even when it's been changed. Once again, always make sure your graphs are filling out the entire graph. There we go. That's the cotangent graph. And notice how similar tangent and cotangent are. Okay, just kind of keep those in mind. All right, so now what do these look like when we graph them? Well, first let's talk about amplitude and period. How do we change them? The amplitude for all of these, no matter what it is, it's going to be undefined. But remember that a value will still impact where the graph goes. For both cosecant and secant, since they're reciprocal of sine and cosine respectively, though the period is 2 pi divided by b still. And then cotangent, it's pi divided by b, because tangent is pi, so is cotangent. Okay, divided by b then, and you've got it. So we're going to try one of these, one of each, and hopefully this will make sense. So, all right, here we go. Now, all of these will have asymptotes in there, so kind of want to make sure that you're drawing those in there. The amplitude here is undefined. I know that, but I want to keep in mind that too. Okay, my period is going to be 2 pi divided by 4 over 3, which would be 2 pi times 3/4. Okay, so that's going to give me 6 pi over 4, also known as 3 pi over 2. Okay, so my period would be 3 pi over 2. All right. Now, if you need a refresher, you can always go back up and look at cosecant and what it looks like, right? Asymptotes, the first asymptote starts at 0. That's not going to change. And now I need to, the next one is at pi and 2 pi. So I can figure this out here. So I know I'm going to have an asymptote right here. Okay. Now, I also know that I'll have another one. Normally it's at 2 pi, but now it's going to be at 3 pi over 2. Okay. But I need to do an up kind of parabola and a down one in between there. So that means halfway in between here, I'm going to have another asymptote. And so now I can just fill out the rest of these. I've got one every 3 squares. Okay, and all right, that's pretty good. So now I just need to say, all right, how can I fill out the rest of this? Let me C. Okay, so my A has changed. So instead of going at 1, I'm going to be at 2. Now in here, let's do my first one. I know it goes up. Well, halfway in between these two right here would be at right in here at 2, so halfway there. And then down here at -2, halfway in between those asymptotes. And then same thing. Now I just want to continue that pattern. Okay, now just draw it in. It's a little bit off, but looks a little ugly. Okay, there we go. That is cosecant. And we've changed that amplitude and period. All right, I hope that makes sense. Let's try the secant one. Again, if it's helpful, you can always go up and look at your other one. Okay, so amplitude undefined. But I know I need to keep in mind this 3, right? My period is going to be 2 pi divided by 2, so that's pi. Okay, so my period is pi. All right, so now let's just take a look at what we have going on with the secant one. The secant one might be one of the ones that's a little bit trickier to graph. Now notice this first one here, that's a total distance of pi, but it sort of straddles the y-axis. So when I cut that in half, so this one is pi. So let's see, if I put one here, whoops. Okay, that's a half pi, but I need to do an up and a down, so that's, man, struggle. Okay, so now that would give me a period of pi for my asymptotes, because I would have the up in one of these and the down in one of those. But this first one kind of straddles, so you got to keep that in mind, a little sneaky. So secant is probably the trickiest one. So I think, so now I can just draw in the rest of my asymptotes a little bit better than I'm doing here. Okay, back this way. Maybe do a little better than I am here, but okay. Now this, I'm going to have a whole ton, right? I'm going to have a bunch of little teeny secant graphs plopped in here. So hopefully this looks all right. Now this one starts at 3, so I'm going to have a dot here, and then -3, 3, -3, 3. Okay, and then we're just going to fill these in. Oops. Okay, and there we go. That's secant. like I said, secant's the trickiest one because of this kind of straddling the y-axis. Okay, one more. Let's try one more. The cotangent one. Cotangent tends to be the easiest to graph. And remember, why is that? Well, cotangent, the asymptote starts at 0, but also the period and the first asymptote match. So that makes it easier to kind of figure out where it's going. So let's get to it. All right, so cotangent. My amplitude, again, is undefined. My period here would be pi divided by 1/2, also known as pi times 2/1, so 2 pi. Okay, well, this does make it a little easier. Like I said, I know I have an asymptote line right here. And since the period and the first asymptote are the same, I know I have one at 2 pi. That means I have another one back at negative 2 pi. Okay, and oh, I don't know what happened to the rest of my graph there. There we go. Okay, now in between here, I should be at 0. So halfway in between these asymptotes, I'm at 0. That would be at pi. Now, this is going to go 4. So halfway in between here, I should be at 4. Because remember, cotangent flips around the other way. And then this one will be at negative 4. So here we go. Okay. So it's going to look almost like a straight line because it's so spread out, but it's not a straight line. Just kind of give it a little bit of shape. Okay, and that is cotangent. That one wasn't too bad, right? All right, so now that you know how to do that, you should be able to do your assignment on graphing reciprocal functions. Good luck.